Imagine checking a suitcase at an American airport. You put it on the scale. A tag gets attached, and then it disappears behind a rubber curtain. For you, the journey seems to stop there. But behind that wall, your suitcase enters one of the strangest logistics systems in modern America. It can be scanned, diverted, screened, sorted, stored, and routed through a maze of conveyors before it ever gets near your airplane. And every decision has to happen fast. Because the airplane isn't waiting for your bag. Your bag is racing the airplane. An airport baggage system is essentially a factory built to process objects that don't behave like identical factory parts. Every suitcase is different. Different sizes, different weights, different destinations, different airlines, and sometimes different connecting flights. Yet the system has to turn that chaos into a predictable flow. The first step is identity. Your bag receives a unique identifier. That identifier becomes its digital identity as it moves through the airport. Modern baggage systems use scanners, sensors, and routing software to determine where each bag needs to go. IATA's baggage tracking framework requires airlines to be able to track key custody points, including acquisition, delivery to the aircraft, transfers, and final delivery. So the airport isn't just moving luggage. It's tracking individual pieces of luggage through a network. Think of your suitcase like a package entering a massive automated warehouse. Except this warehouse has aircraft departures as deadlines. A scanner reads the bag's identification. The control system knows its flight. And the conveyor network starts making decisions. Left, right, up, down. Sometimes the bag moves through different levels of the terminal. At LaGuardia, the new baggage system was designed to handle up to 40 million bags per year, with capacity of roughly 6,000 bags an hour. That's not a conveyor belt. That's an industrial-scale sorting network. And the remarkable part is that the system doesn't need a person standing beside every suitcase telling it where to go. The infrastructure itself makes the decision. But getting your bag to the right aircraft isn't enough. It also has to be safe to load. Before checked baggage reaches the aircraft, it goes through security screening. TSA's current system uses explosive detection systems, including CT-based technology, with additional screening when necessary. That creates an unusual engineering problem. A suspicious bag can't simply stop the entire baggage network. The system has to isolate it, route it somewhere else, and keep cleared bags moving. LaGuardia's baggage system uses vertical sorting units that can divert bags between levels depending on whether additional screening is required. So somewhere inside the airport, your suitcase may suddenly change direction because a machine hundreds of feet away made a decision about it. And you never see any of it. At this point, it would be easy to think the hardest part is simply moving the bag. It isn't. The hardest part is coordination. Imagine your suitcase is flying from Atlanta to Denver. But you aren't staying in Denver. You're connecting to Seattle. Now your bag has a deadline inside a deadline. It needs to arrive at Atlanta's baggage system, get sorted, reach the correct aircraft. Fly to Denver, leave that aircraft, enter another baggage network, and reach your Seattle flight before the doors close. This is where the system becomes extremely sensitive. CETA's latest data shows that transfer baggage accounted for 39% of mishandled baggage cases in 2025. The system can move bags incredibly fast, but speed isn't enough. It needs coordination. This is where airport infrastructure gets interesting. You can't simply replace a baggage system the way you replace a conveyor in a warehouse. The airport is already operating. Aircraft are still arriving. Passengers are still checking bags. Security is still running. And enormous amounts of infrastructure may already be buried inside the terminal. Heathrow is currently investing hundreds of millions into baggage modernization, including a new dedicated system for Terminal 2. Its multi-year project has a stated value of £885 million. In the United States, Pittsburgh International's terminal modernization includes consolidating its baggage handling system into a new 700,000 square foot landside terminal and is intended to reduce baggage processing time. So the future of baggage isn't simply about better machines. It's also about replacing infrastructure while the airport keeps functioning. And something important has changed. The baggage system is becoming increasingly digital. IATA's Resolution 753 framework pushed airlines toward tracking bags at multiple points in the journey. RFID can supplement barcode-based identification. Real-time data can reveal where a bag was last recorded. And newer systems can use automation and data to make routing decisions faster. The results are measurable. In 2025, the global mishandling rate fell to 4.9 bags per 1,000 passengers, down 23% from the previous year. So this isn't a story about a system that technology has failed to fix. It's almost the opposite. Technology is working. But the next question is, what happens when we stop designing baggage systems around the airport of the past? If we designed an airport baggage system from scratch today, we wouldn't start with a conveyor belt. We'd start with the bag's identity. Every bag would have a digital record. Every movement would update that record. And instead of simply asking, "Where should this bag go?" the system could ask, "Where does this bag need to be next? And what is the safest, fastest route to get it there?" The physical network could then become more modular. Automated storage could hold bags until the correct departure window. Robotic systems could reduce repetitive heavy lifting. And smarter routing could continuously adjust to congestion, delays, and changing flight conditions. Some of this is already moving from concept to reality. Van der Lande's bag load system, for example, is designed to automate baggage loading and reduce heavy manual lifting, and the company says it has been refined in live airport operations. The future isn't one giant robot replacing the baggage department. It's a network where machines handle the repetitive movement, while people handle the exceptions. Now imagine that system. You check your bag. It receives its identity. The airport knows your flight. It knows your connection. It knows the expected route. Instead of sending the bag blindly through a fixed sequence, the network continuously routes it toward its next required checkpoint. A robotic system moves heavy bags into position. Automated screening handles the routine flow. Storage systems hold bags that arrive early. And when a flight is delayed, the network doesn't necessarily have to collapse into chaos. It can begin recalculating. Because the modern baggage system isn't really about conveyors. It's about coordination between software, machines, people, and aircraft. The conveyor is just the part we can see. But there is a catch. Automation isn't free. Airports operate in incredibly constrained environments. Existing terminals have limited space. Security requirements can't simply be redesigned away. And every new automated component creates another system that has to be maintained, monitored, and integrated. So the future probably won't be a completely human-free baggage system. It will be something more practical. A system where humans deal with the unusual cases. While machines handle the predictable ones. The next time you check a suitcase, watch what happens. The bag disappears. And somewhere behind the terminal walls, a network of scanners, conveyors, computers, security machines, and people starts working. It doesn't look like a factory. It doesn't sound like a warehouse. But that's what it is. A hidden logistics machine built around one impossible requirement. Get the right bag to the right aircraft at exactly the right time. And as airports become more connected, the next generation of baggage systems may finally stop looking like conveyor networks, and start looking like what they really are: intelligent logistics systems.